Okay, question 8 is one of our least and greatest value questions. So it tells us that a warehouse stores electrical goods in boxes, and the boxes are all cuboids. So remember that your cuboid is like your 3D rectangle. Now it says one of the boxes has a depth of 46 centimeters, a width of 55 centimeters, and a length of 62 centimeters, where all the measurements are correct to the nearest centimeter. So that means that it could be half a centimetre below or half a centimetre above. So write down the greatest and least possible values for each of the measurements in the table. So if it's 46 centimetres, then so the smallest it could be is 45.5 centimetres, and the biggest 46.5. The width is 55, so that's half a centimetre smaller is 54.5, half a centimetre bigger 55.5, and the length half a centimetre smaller than 62 is 61.5, and half a centimetre bigger 62.5. So there's your first 2 marks. Now it then says that we need to hence, so hence means using something from part A, calculate the greatest possible volume of the box. So the greatest possible volume of the box, the volume of a cuboid, we know, so the volume of a cuboid we know is our width times our length times our depth, or height you might have heard before. And so if I want the greatest possible volume, that means I'm going to have the largest possible size of each of my dimensions. So it's going to be the 46.5 times the 55.5 times the 62.5. And so if I multiply those together, I end up with 161,296.875 centimeters cubed, or if I rounded that, 161,296.9 centimeters cubed. Now part B again is now using the same things as we've done in the first question, but it's introducing dimensions: x centimeters, y centimeters, and z centimeters. So we had 46 centimeters, 55 centimeters, and 62 centimeters. So they're just using x, y, and z instead of those. And again, they're saying each of the measurements is correct to the nearest centimeter. So remember, in the original ones, when it was correct to the nearest centimeter, we did half a centimeter below. So it says find an expression for the least possible volume of the box in terms of x, y, and z. And you don't need to simplify your expression. So if we remember, the greatest was when we added 0.5 to each of our lengths. This time we're trying to find the least, so we're going to take away 0.5. So x, take away 0.5. It's going to be the smallest in my first dimension. Because I'm working out the volume again, I'm going to times them all by each other. So y minus 0.5 would be the least my y centimeters could be, and z minus 0.5, the least my z centimeters could be. And that's all they're asking. Because they've said we don't need to simplify, that's all they're asking for the 2 marks.